Hello and welcome to the afternoon session of the QBio's virtual epidemics modeling workshop. We are reaching now the last stages here of this two-day event, and it's my distinct pleasure to introduce two folks who are going to be leading you through an interactive demonstration of the ways in which we can take the principles that we've gone over the past day and a half and translate them into interactive dashboards. And again, if anyone is joining us who hasn't already been in the workshop, my name is Joshua Weitz. I'm Professor of Biological Sciences here at Georgia Tech and the founding director of the QBio's PhD program. And today I'm joined with two scientists, really bioinformatics scientists, Dr. Lavanya Rishishwar and Dr. Aroon Chande. And Dr. Rishishwar is a senior bioinformatics scientist and developer at the IHRC company, and really is at the center of the Applied Bioinformatics Laboratory. Dr. Aroon Chande is a scientific advisor at ABLE, the Applied Bioinformatics Laboratory, and is also a bioinformatics scientist at Seattle Genetics. Both Lava and Aroon received their bioinformatics PhDs at Georgia Tech, and it's been my distinct pleasure to work with both Lava and Aroon on a series of projects that have helped our team translate epidemic models of the kind that you've been working on this past day and a half into a format that even non-modeling specialists can begin to explore them, utilize them, explore parameters and assumptions. And also of note, both Lava and Aroon were critical in the development, the deployment, and really the communication of our COVID-19 risk assessment event planning tool, which many of you have heard about and got to the point which I think they'll talk about today, that we had hundreds of thousands of visitors visiting one of these interactive websites, and none of that would have been possible without their expertise. So today, in the next hour and a half or so, both Lava and Aroon will guide you, giving you a sense of what dashboards are, what they can be useful for, and specifically giving you use cases that would help you translate the kinds of models that we built yesterday and today into action. And just a short note on the material as they'll go over in the chat, Aroon already shared with you a link to a GitHub site that has all the source materials if you want to follow along with the code. And we will be releasing a PDF that they developed that really is an instructional guide that you can use afterwards to go through and try to recapitulate the kinds of insights and techniques that they're going to share with you today. And without further ado, let me hand it over now to Dr. Rishishwar for his presentation. Lava, go ahead.
Thank you, Joshua. I'm going to go ahead and screen my, share my screen. Share options. Sorry, give me 1 second. My computer's taking a minute. All right, there we go.
And we can see it.
Okay, great. All right, so thank you very much for that nice introduction, Joshua. As Joshua mentioned, I am Lavanya Rishishwar, or simply you can call me Lava. I have with me Aroon Chande, and the two of us will be walking you through how you can make your own interactive dashboards. We will be scratching the surface here. There's a lot of depth that we will not be able to touch or go through in this rather short stretch, but what we hope to do is show you what you can do with these software tools, libraries, whatever you want to call them, but with these technology in your hand. And if we can get you excited to go on and explore this on your own, that would make all of us really happy. So the way we're going to go through this is we'll start with some basic introduction so that you will understand who we are, where we're coming from, and how we like to look at things. And as soon as I'm done with that, I'm going to jump into talking briefly about what dashboards are, so that we are all on the same page on what is it that we are developing, what is this end goal that we are trying to pursue here. I'm going to hand it over to Aroon after that, and we're going to do an interactive tag team session there where he's going to walk you through the code base, and I will try my best to represent you as the participants and ask him questions about what is it that he's developing, like how is he thinking, how is he approaching it, what is happening behind the scene there. Once we have done that, we will talk briefly about how you can publish your own application or an app. And then we'll talk more about how you can deploy larger applications, some of the considerations that go in there. So let's get started with who we are. So Applied Bioinformatics Laboratory, or ABLE, we started this as a public-private collaboration between 3 different organizations. This was IHRC, ASSERT. Both of these are local to Atlanta. Consulting firms, they do a lot of contracting with the federal government, state government, and they've done some work with the companies and academia. And on the public side, we have Georgia Institute of Technology, which I'm sure you're now aware of. The idea behind Applied Bioinformatics Laboratory was that we've been building a lot of these technologies at Georgia Tech, well, especially when I was at Georgia Tech, me and my then PI, Professor King Jordan, the two of us thought, well, how can we apply these to, or use these technologies to help individuals who are outside of Georgia Tech, help them solve their own problems. So the kind of services that we provide are very bioinformatics focused, and I understand a lot of you may not be from that area, so this is just kind of an overview for you guys. So anything genomics, proteomics, transcriptomics, epigenomics, so those are anything omics, that's our bread and butter. That's what we do a lot. We do work a lot with molecular typing. So I'm sure you're all now very well familiar with COVID-19 and how it transmits and how you can model all of that. But on the genomic side, how do you figure out what is that lineage? How do you figure out how these different strains are related to each other? So the techniques behind it, that's what molecular typing is, and that's what we do a lot of. Big data, we work a lot with biobank scale data sets. So if you've heard of UK Biobank, for example, where there's 500,000 individual, how do you process that much amount of data? That's something that we've done. Now, all of this is just to kind of give you an idea of this is where we're coming from. This is how we think. And a big piece of this is when we are looking at these hundreds of thousands of individuals, how do you present this information to someone who, you don't want them to spend hours of time trying to understand what is it that you've done. How can you summarize that information for them? This is where the dashboard comes in, and that's something that we've done a lot on. As an aside, we also do a lot of training. So I'm just going to move on to our own introduction. I've done a ridiculous amount of training in my lifetime. Since I've been doing it, it's been easily over 1,500 hours. Maybe it's closer to 2,000. I've lost track after that number. I do a lot of publishing, so I like to work in a lot of different areas, and the areas that really interest me are algorithm development, machine learning, and really computational genomics of microbes or human. So that's a little bit about who I am, where I'm coming from. Aroon, if you could briefly introduce yourself as well.
Sure. Okay, so I'm Aroon. So I've also been working in bioinformatics now for quite a while. I guess I come at it from more of a development and platforms point of view. So I actually joined ABLE when I was still doing my master's at Georgia Tech. And then during my PhD, I founded my own startup basically doing bioinformatics consulting and platform development work. And that's since transformed into a full-time job doing development work in the biopharma space. So yeah, I really enjoy this platform development kind of stuff, so I'm happy to talk about it today.
Thank you, Aroon. All right, there we go. Okay, so everything that we'll be talking here will be referring to, we'll keep coming back to the Schol immunity, which is one of the latest dashboards that we've developed with Joshua and his group. And I'm sure some of you are familiar with this, but if you're not, there's this Nature Medicine article on it that will tell you more about what the underpinnings are. And more specifically, the one view that we'll keep coming back to is this proof of concept expert view, where what you're seeing on the screen, this is one of the many things that we've done with Joshua, but this would be the use case. This is sort of what we'll try to recreate at some level today. All right, so with that, we'll start with dashboards. What are dashboards? Outside the computer industry, dashboards you would be familiar with as a dashboard in a car, where you have a lot of different metrics appearing on the screen that tells you the state of your car. So for example, how fast is it that you're going? How much fuel is remaining? Are there any engine issues? Is your engine overheating or something, right? So there's a lot of different things that dashboard tells you that you get used to, and you don't need to be an expert to know, oh, that my gas is out, I'm out of gas, right? So it's informative, it's useful, it's right there, it tells you everything. Now from the business standpoint, and this is a screenshot straight from Wikipedia, but it captures very well what it is that dashboards intend to achieve. So there's a few things here, so I'm gonna move on. So the few things that comes up here are, number one, they're graphical interfaces. So it's not a dashboard's basic premise is going to be that something that you can see on a web browser. It's going to have some visual elements associated with it. There will be some key metrics that you're summarizing, right? And overall, your objective with the dashboard is that you're monitoring certain scenarios, and this can vary a lot. So you could be modeling with respect to this particular workshop, you could be modeling your COVID-19 risk, for example, and the dashboard will tell you what are the risks and in different counties in the United States or across the world. Or you could be using dashboard for monitoring what the server usage is, or you're into finance and you're looking at different financial aspects, or you're doing some sort of business intelligence, right? So dashboards are quite generic. There isn't a set items that a dashboard needs to follow or set of rules that a dashboard needs to have to qualify as a dashboard. It's really an interface that gives you a summary of certain key metrics that allows you to monitor the situation. That's the idea behind dashboard. Now, you probably hadn't heard of it a long time ago. It's a rather recent thing that it has gained popularity, and the big reason behind it is the rise of data science. We are living in a time where there's a lot of data. We are constantly being deluged by, all right, here's data coming from this stream, that stream. How do you make sense of it? And dashboards sort of become a nice end result from a lot of heavy lifting that you do. What they do is they give you sort of a 5-minute pitch of the situation. So you don't have to spend a lot of time. You can be coming from several different fields, and if done correctly, a dashboard will give you a quick idea of whatever that summary is that it's trying to present. Another reason why these dashboards are very useful these days are the ease in which you can collect and generate data. It's a lot easier now to collect data than what it used to be before. We're also living in a post-internet era, so it's no longer an issue that, oh, there are data sources that are out of reach. Everything, or almost everything, you can find on the internet these days. A lot of these resources are also moving towards, if I could broadly say, harmonizing the way that you can access them. So, for example, trying to access county level data from different states, that's become a lot easier than what it used to be before. Of course, there's a lot of challenges there. It's not beyond challenges, but all of that, those small progress helps a lot. And finally, the big push that has helped make these possible is the advancement in technology. So you have the hardware. Earlier, you used to maintain your own server. You have to have an IT administrator who's handling the whole thing. Well, now you don't need to do a lot of that. You can use a lot of these cloud-based resources that will do the work for you. If you do want to go into more detail, you can, because you have a lot of options. So it's not like a single cloud provider. There's so many of them that you can go and shop around, and you can pick from what are the features that you like better. From the software standpoint, there's so many modules and packages that you can utilize to create this dashboard and make it your own, customize it the way that you like it, with a lot less effort than what it used to be, right? So, and the final point here is the urgency of mass information dissemination with COVID-19 really put dashboard at the forefront, and you started seeing a lot of it. So, having talked about what dashboards are, let's switch gears to how do you make a useful dashboard. And to really summarize the things that you need to make dashboard, it comes down to these four. The first one is a need. So you can't just make a dashboard for the sake of making a dashboard. I mean, you can as an academic project or something, or part of a class, but if you want to make a dashboard that is useful, it should be solving some problem. There should be a need for it, right? So what is the need? What is the solution? That's something that you have to figure it out. So it goes without saying that this is beyond dashboard. This is really a subject matter expertise that you need to bring and say, this is something that I specialize in, that I can report, or that I can make a contribution that no one else can. And here's a solution for that. The next one is your technology. And there's a lot of different options that you can pick from. On the top right here, you see Shiny from our studio. That's the one that we're going to use for this session. We like Shiny a lot. It's a really, really nice package. It makes or it allows developers to make these dashboards in a much shorter time frame than what others do. But Shiny is not the only one. You don't like Shiny for whatever reason, you have the option to go with Python Dash, right? So it's really Plotly. That's a Python-based package. You're a JavaScript person. You can use Node.js. And then some of you may have heard of Tableau as well. That also provides ability to make dashboards too. Which of these is the best? That comes down to rather it's an opinion. Every technology has its own pros and cons. Each technology will have its own free and paid version, and quite honestly, the perfect technology for you is the one that you can afford based on whatever your expenditure is for the project, and for which you can find developers and maintainers. So for example, I can talk about Shiny and everything, but say you have a JavaScript-based developer. Well, then there's going to be a decent time investment for that developer to pick up what Shiny is, then maintain it and do it right? So you have to make those decisions based on what resources you have. That's the ultimate way of making the decision there. As I mentioned, we like Shiny for small scale projects. It's excellent. It takes us the least amount of time. As our scale grow quite big, and when I say scale, I'm really referring to the data that we're analyzing. Shiny can do it, but we start migrating more towards Python Dash because inherently R is a little bit slower when it comes to data processing. Node.js is JavaScript. Majority of developers code in JavaScript. There's nothing wrong with it, but people have strong opinions when it comes to JavaScript. And then finally, Tableau is good, but it's one of the more, I think the only paid one of these four. It's not as pliable as we prefer it to be, but it's definitely a good technology if you would like to use that for making these dashboards, right? And finally, you need people, because technology, solution, and all of that is great. Someone has to execute your project, and that's where your developers and project managers will come into play. Developers will do the actual development. Project managers will make sure the project stays on course. It doesn't, basically that you can deliver when you want it to be delivered. All right, so I'm going to take a quick pause here, make sure there's no questions.
None yet. We'll let you know if there's some questions in the Q&A.
Right. Seth has that no Power BI. I mean, Power BI is great too. I mean, I wanted to pick 4. That was the 4 that I picked. There's by no means was that an exclusive, exhaustive list. That's just some of the more popular ones. Power BI is definitely another one that you can use. So Seth, that's no hate for Power BI. It definitely exists. I just didn't think of it. All right, so with that, I'm going to move on to Shiny and introduce to you guys what is Shiny. So Shiny is an R-based rapid dashboard development package. R, if I know some of you may have worked through it, and if you are not familiar with it, R is a very high-level language. It is very easy to learn, but it can be inefficient for large-scale data operation. The good thing, though, is a lot of stuff that you would like to do, a lot of data operation that you'd like to do, they're already implemented within R. So with little effort, you can process a lot of data. So it really comes down to whose time do you value more? Do you value your own time or do you value your computer time? And there are scenarios where you have to pick one or the other. But let's briefly introduce what is R. R is one of the several popular languages that are used for bioinformatics, statistical analysis, and data visualization. It's bioinformatics, and all 3 of these are what interest us, and that's why we use it a lot. It is a successor of S, and amongst its peers, I would put MATLAB, SAS, and Octave. Again, there can be others. No offense to them, but those are the 3 that comes to my mind. As I said, it has a very high-level language. It abstracts all the nitty-gritty details from the user. The benefits of R is it's easy to learn and use. It has it's an expansive set of packages and user base. So a lot of what you would like to do, you can search on Google and figure out how to do it. As a fun story, when I started learning R, I didn't pick up a book. I just started doing it. I started Googling, how do you do this? And then figured it out from there. So it's really easy to pick up R. It is great for generating visualization. I mean, there's a lot of languages that can do it, but R has by far the best one that I found. And finally, developing interactive dashboards is quite easy in it. Why do I personally like it is, as I said, the abstraction. A lot of things that I like to do, we do a lot of statistical tests, and with R, that happens a lot more easily than compared to the languages. Data visualization, I personally do a lot of it. I've made Aroon do a lot of it too. I don't know if he likes it or not, but he does it a lot. But the 3 pictures you're looking at the bottom are some of the pictures generated through R. I think they're beautiful, at least in my eyes. I hope you'd agree, but there's a lot that you can do within R. A lot of these graphs, plots, you can generate in R with a lot more ease than other languages. And then finally, web development, as I've been saying, it's a lot easier. Now, what you will be seeing, and I'm going to be turning it over to Aroon in the next 3 slides, but we'll be seeing us working in RStudio. And it's going to look something like this. So just so you are aware, what is it that you're looking at? RStudio is an IDE, or an integrated development environment. So I'm going to write here. Yeah, right. So it's an integrated development environment. All that means is it gives you a lot of different tools that helps you code faster. So that includes, color coding the code that you're writing, but they'll also help you with debugging and stuff. You're going to see that Aroon will be working on a console here. This is where the actual R stuff will happen, and likely that console will drop down and a file will open in this place right here. There's going to be environment, so any variable that Aroon creates, they will be listed on this side. And there's also a history tab, but I don't think we're going to deal with that here. And down here will be, files, plots, packages, and stuff like that. But this is broadly what you'll be seeing. RStudio is free. There's a paid version too, but I've never paid for it. Most of what I've done has been for stuff for free. Now, Shiny is a package within R, and this is where, when you're scaling up, you start. I'm going to hold off on that thought. I'm going to come back to it later. But anyway, so let me start with Shiny first. So Shiny is a framework that allows developers to rapidly develop and deploy complex interactive applications purely written in R. And the idea behind this was that you don't need to know HTML, CSS, or JavaScript. It's good if you do, because that helps you with tweaking the page to look exactly how you want it to, but you don't need to know them. All you need to know is how does R function, how does Shiny library functions, what are the different modules, and you can put that together to create a nice dashboard. It's great for developers of all experience levels. So if you are a novice developer, you're starting for the very first time, the syntax level is quite high level, and the structure is very simple, as you're going to see in the next few slides. So you don't really need to know a lot to make these dashboards. But if you're an experienced developer, you will observe that there's an adherence to strong software engineering principles within it. And that allows you to make applications which are, which you'll agree with, that it's organized properly. It follows the principles that most developers like to follow, right? So this is going to be the last set of slides that I'm going to talk about before turning over. But this is how Shiny application work. So you're going to be on the right-hand side. You are the user right here. And every time you interact with an application, you will be interacting. So for example, there's a remote server on which this application is hosted. And let's say this application is the Shield immunity application. It's hosted up here. There's a web server that is handling your responses, whatever you're doing, and it's passing it on to the Shiny application. Now the Shiny application will have two components to it. There's a reason I've written it in this case, but the two components are going to be the UI, or the user interface, and the server, right? So what are these components? Your UI will handle the instructions for creating a web page. This component is where you will code all the interactive elements. So what we'll be doing is we'll be making sliders. So the information about the slider will go into the UI. The server will contain instruction on how to react when the user interacts with your dashboards. For example, the user changes the slider. That information will be sent to the server, which will be another function. And within that, you as a developer will handle what needs to happen when this thing changes. Typically, you will have a code that will describe how to replot an existing plot based on the new input that the user has applied, and then send that instruction back to the UI, and then follow it all the way back to the user, and the user will see the new graph. So this is an overly simplified architecture of Shiny. But hopefully that'll get you some idea of how all of this is going to work. We've pasted this link on the chat. Aroon has has written it up there. But if any of you would like to follow along, what is it that we're doing, and you want to look at the code as Aroon is walking you through it, feel free to do that. But with this, I'm going to stop sharing, and I'm going to turn it over to Aroon, who will walk you through how to make your own applications. So Aroon, take it away.
Great, thanks, Lava. All right, so as Lava's already pointed out, in the chat, you'll see a link to this GitHub repository. There's no reason that you have to download and follow along directly right now. If you want, you can just sit back and absorb the information. Otherwise, go ahead and download the data that we have here. Essentially, this is going to cover all the bits that we're going to talk about. If you've never used R or RStudio before, you will have to do some setup before you can run the programs that we're providing. That's mostly just installing these two packages that you need. First one is Shiny, and the second one is DEsolve, and that's used for doing some of the SIR modeling. We're also going to be using the Shiny Apps IO platform for doing our publishing, and all that means is you have to create a free account here. Again, you don't need to do that right now, but in your own time when you want to play around, go ahead and do that. All right, so we'll get started by so eventually at the end of the session, we're going to wind up building this application. It's not going to quite look like this because we're going to use the base plotting libraries in R. The application we're using a slightly fancier one, so you get some like interactive elements. But you'll get essentially this graph. Let's start here. This is again the RStudio IDE. I just have a new file open that I'm calling scratch.r. But we're going to go through these 9 example applications in Shiny. We'll start out with the simplest possible thing, which is a hello world example, which essentially you do in every programming language when you're first learning it. We'll again work our way all the way down to doing essentially a complete epidemiological modeling application. Let's start by loading the required library that we need. So if you're not familiar with R, we load libraries and packages with this library call, and inside that then you put the name of the package you want to load. The way Shiny applications are set up is there are essentially 2 big components. You have a UI, which is the front end, so it's what people actually see, and you have a back end, and that's again going to be all the code that handles, say, plotting an image or taking input and transforming it in some way. So we'll start with the UI. And the simplest format of the UI that you can create is called the fluid page. That's all it is. And we'll say hello world here. And we also have our backend or server. We'll call that server. And server is actually an R function. So it has inputs and outputs that it interacts with. So we'll say function input output. And this actually is required for all Shiny servers. The server function will always take a named input called input and a named input called output, as confusing as that might be. For now, we're not going to worry about handling any specific things in the server function. It just needs to exist. And finally, we'll make our actual instance of our application. So our application instance then needs a UI, which we have right here, and it needs a server, which we have here. I go ahead and save this file and then run the application. We'll see in this viewer pane that I have a new website that opens that says Hello World. I can actually open this in Chrome if we care. And again, you see that exact same thing. If you're curious what's going on here though in the background, we look at this UI object that we're making. It's just HTML. If we look at the actual like stuff inside this, is just HTML. We're making a div that's a fluid container. Then we have this text inside of it, hello world. Server itself is a function. So again, if we go, we were just to inspect the server function, we have a function that returns nothing. It doesn't do anything. But we can actually make this quite a bit fancier if we want. We'll actually start off by, I guess we'll first do a classical input that we have. We have this fluid page, and we can actually add more things to this. Let's start by adding another line.
Aroon, before you go on, what is this fluid pages? Why is it called fluid? Why is it container fluid?
Sure. So by default, Shiny uses the Bootstrap framework. So Bootstrap was originally developed by Twitter, and it's actually their like theming and JavaScript framework. So it provides a nice cohesive set of ways to make your HTML website look, but also basic interactions that you might need. So in Bootstrap, the simplest type of container that you can make, which is essentially a part of the application, is a fluid container. And all that means is it resizes as you resize your browser window. So it's not just a fixed piece of text or a fixed image. It will resize as you move your browser. So again, if I add more things to it, it shows more text. But again, we generally want to do more things than just display some static content. Usually actually we want to do some sort of interaction. So the simplest type of interaction you can do is looking at a couple different input types. So in the PowerPoint that we'll share with you after the session is done, we've provided a quick overview of all those input types. But I'm going to give you one of the most common ones that we use for, say, like an epidemiological modeling application, where you want to vary, say, the value of a variable inside of your model. For that, we use something called slider input. The slider inputs, as the name might imply, is just a slider that you can move back and forth to select a value. Slider input has some required arguments to it. It has input ID, which is actually usually used for everything, for every input in a Shiny application. This is the name of the variable in the input list that you'll see when you actually want to refer to this. Let's call this guy alpha, assuming that it's the alpha variable in our model. It also has a label. This is what we're going to call the slider on the actual page when we see it rendered out. We'll call this strength of shielding. So again, we're going to look at something like the shield immunity model. Finally, we need to tell Shiny what are the possible values that the slider can take on, and what do we want the default to be. So by default, we'll say our input value is 10. We'll say the minimum it can be is 0. Max it can be is 20. And because we want to give the user some amount of adjustment, but not unlimited adjustment, we'll say the step size is equal to 0.2. That means you can go from 0 to 20, counting by 0.2. I go ahead and save that and reload this application. Now you can see that we have the slider input. Right now it doesn't do anything other than let you play around with it. And the reason why it doesn't do anything is we have nothing in this server function. So even though we have something that users can interact with, that is the slider input, we're not doing anything with that input data. So right now it's sort of just like going into a black hole.
Arun, before you move on, are there rules for what that input ID has to be, or do we really need that input ID?
So yes, you really need the input ID. There are actually a couple, depending on the input and like bit of Shiny widget you want to include. They may or may not have different required variables, but most of the inputs do require an input ID. When you think about naming them, I would choose names without spaces, because that will make your life easier, as I'll show you in a little bit. That input ID is actually how you'll refer to, say, the value that slider takes on in your code. So it should be descriptive, but it shouldn't be a sentence long. All right, so we have this slider input, but we should probably do something maybe more useful with it than just have a slider. The very first thing you can do here is say, let's make a plot using the input that we have here as part of the input to that plot. So to say that you're going to have a plot, you say I have a plot output that I want to be here. And again, this takes an ID. In this case, it's the output ID. We're going to make our lives easy and just call this plot. Anytime we want to send an image to this plot output, we'll just say send the image to plot. Next up, we will build up our server function. So we have a very basic UI. Let me save this first. So I have a plot output now that appears in my UI. Actually, stop this. If you look at this UI output now, we have a bunch more things that have been added to it. First, again, we have fluid container, which is fluid page up here. We have our hello world text again, which is first line under fluid page, which is hello world. Then we have our input for our slider input. So Shiny does all the hard work of translating simple slider input function to this HTML that then gets rendered out to users. And finally, we have our plot ID. And as you notice, we've called this output ID plot in the div ID down here, which is how we identify parts of HTML, is called plot. We have our server function. So in order to say send image to that output called plot, we'll look at that input variable called output, and we'll say plot. What the $sign here is doing is saying, I have this object called output that I'm feeding into my server function. And I want to work on an item inside of it called plot. I'm going to assign a value then plot. So in Shiny, the way you render out a plot is you use the function render plot. Render plot, all it needs to happen at the end is the very last thing executed or the last thing returned by the function needs to be a plot or some image that can be rendered. So we'll make a very simple example where we'll use seek, which all that does is produce, in this case, numbers 1 to 10, counting by ones. So if I look at x, we have -10 to 10, counting by ones. Now we'll make y in our graph be pulled from a normal distribution. We'll pull from the normal distribution using the, we'll say the mean is going to be based on the input that we're providing in that slider. So yeah, I'll take that back. Let's set our standard deviation just so it's a little bit easier. We'll say it's centered around 0, so mean. Then our SD of this is going to be equal to our input. Then we have an input and it's named alpha. Input. And finally, we'll plot these two bits of data against each other. X, Y, and then I want this to be a line, so it's going to be type L. Go ahead and save that. We'll run this application. There we have a very simple application that's taking in standard deviation, and it's producing this reactive graph. So every time we change the value of shield, we get a different distribution being drawn just based on that standard deviation from this input value. Any questions there?
I'll ask a few questions while the audience may type some. Now, if I'm understanding this correctly, your render plot is a function, but then you have multiple lines within it, right? And it's just going to execute one after the other. Now, if I were to make this myself, where will I want to make? So what variables can I rename and yet receive the same plot?
Sure, so you can actually rename any of these input or output ID. So I could make this input ID, for example, be SDev for standard deviation. I can make this plot be called demo plot. And I just changed then the respective input and output IDs down here. Then this then becomes demo plot, and this becomes SDev. I reload this page, it still works. If you forget to rename your variables though, you'll wind up with usually an error in Shiny. And this can be kind of confusing. Here it doesn't tell you necessarily that your input variable alpha doesn't exist. Instead, it says you're trying to provide a non-numeric argument to it. Again, and the error down here is also not necessarily super informative, but usually you can work your way back. It says, okay, the error is somewhere on line 19. And I know in line 19 that this variable needs to be renamed. So Steph asks, do we have any thoughts on Flex Dashboard? So Flex Dashboard is just essentially another way to lay out Shiny applications. They really come at Shiny from the R Markdown point of view. So instead of taking, say, a model and converting it to Shiny, instead you might have like reports that you've written in R Markdown. You want to make those interactive. The Flex Dashboard is a great way to take an R Markdown document and essentially transform it into an interactive Shiny application pretty quickly. So Andre asks if there is no autocomplete. So there is some amount of autocomplete. Inside of render plot, you won't get suggestions for what sorts of code to write. But if you use like a standard function from R or an imported function from a package, you'll get autocomplete there. And depending on your IDE, you may or may not get like the type hints for this should be called demo plot. Like here, I can't see it, but I'm pressing the tab button to try and get a completion here for the output. RStudio, unfortunately, even though it's like suggested as the premier IDE for R, it does fall down in some small places, and this is actually one of them, where it doesn't have great support for completing your input and output IDs. Oh, I'll also note, yeah.
Yeah, go ahead.
Oh, so just on a note on autocomplete, so I'm writing out like these slider inputs and stuff on multiple lines, just so that it's very obvious what's going on. But say if you like hit the next line and hit tab, it'll actually insert tabs. Whereas if you're on the same line and you hit tab, it'll actually give you essentially the different arguments that can be given to the slider input function, which we're not using a lot of them here because there are a lot. But it will give you some hints about what you can give to that function for value and min, max, and step.
Aroon, if now I want to do multiple sliders, so let's say I want a slider for mean as well, how can I do that?
Sure, so that's actually pretty simple. We'll actually add it here at the top right under Hello World. We'll just add a new slider input up here. Call this input ID mean, label it as the word distribution. We'll start value out at 0. We'll make the min -5, max 5. I guess we'll leave the step the default. Give it sort of a course, that's okay. So I've called this input ID mean. So down here in my normal distribution, I'll replace the 0 with input mean. I go ahead and reload this page. Now we have these two sliders, one for mean in the distribution and one for strength of shielding, or what we call SDEV here. Let's make this deviation. So if we change the mean, you scroll down here, our mean is slowly shifting over. Again, standard deviation, it's that same slider we saw before. Ian asks, can we use ggplot? Yes, and now in fact, I would strongly encourage you to use ggplot. I don't know. Well, I know Lava really likes baseplot, and we've chosen to use baseplot here just because it doesn't require any additional packages, and it's perhaps more easy to learn. No, personally, I love ggplot, and I never touch baseplot unless I'm teaching our courses, because baseplot hurts my head a little bit. But I love ggplot.
Yes, and the base plot here was the same rationale because it's easier for everyone to understand. You can see plot and it's just plotting. But ggplot, I would recommend that strongly too, especially if you want to make anything that looks professional.
Yeah, like ggplot is really, or rather baseplot in R is very equivalent to like matplotlib and matlib, and but ggplot is a much more powerful way to create plots, and also it gives you much more control over the aesthetics of it. So if you really are serious about getting into data viz with R, strongly recommend that you learn how to use ggplot.
Right, so moving on with this, I don't like how the sliders are placed on top of each other. Is there a way to Can you rearrange the sliders? Can you make them go right next to each other? Do you have that capacity here?
Sure. So first, let's open this in an actual browser window, so it's not just maybe because it's a super thin view. So as you can see here, so we have everything on a fluid page. So if I make this narrower, it gets narrower, and the plot will actually replot itself. If I make it wider, again, everything follows you. But this isn't like maybe ideal. Kind of weird that these two sliders are stacked on top of each other, and it like pushes stuff down the page when it doesn't need to. So we can actually get around that by using, again, an additional helper function that's a lot like essentially the bootstrap functions where it comes. What that is it's using additional UI element called fluid row. So fluid rows so all fluid row does is it creates essentially a row. So if you remember before, if I have this text here right next to hello world, it actually appears on the same line. And that doesn't matter if I put a carriage return here. It'll still show up on the same line. And that's because as far as this is concerned, these two items, hello world and this is text, are on the same level in HTML. They actually show up right next to each other if we were to look at that HTML that's being stored in the UI object.
So is the fluid row like a table? Can you make like rows and columns there?
Yeah, so fluid rows are like a table. So for example, we have this fluid row. And I'll go ahead and put both of these into a fluid row. So if you just do this, it won't actually look any different. Even on this bigger app page, they're still stacked on top of each other. However, fluid rows let you do something called columns. So columns are super handy because you can define then a grid that your application will take on. So by default, column, what it takes in is the width of the column you want it to be, and then what goes into that column. In the Bootstrap world, pages are subdivided into 12 equal-sized columns. So we'll actually go ahead and say that the width of this column is going to be 3. We'll do the exact same thing down here. Put this slider input its own column. If I reload this page, now they show up on the same line. What this is these are both in a row together. And I've said both of these are going to be a width of 3. I could make the widths larger, up to 12. So for example, could make this guy 6. And this, so now this slider is taking up 6 arbitrary units on the page. In this case, it doesn't really matter. We don't care about the layout to that degree here. Set this back to 3. The nice part about using these fluid elements, though, is if you make your tabs smaller. So, for example, if someone were to use this on a mobile phone, if your screen gets small enough, they'll actually start stacking these together. So it will automatically rearrange your application to at least look a little bit better on mobile. It might not look perfect, but you won't have this giant widescreen application that's completely unusable.
You mentioned mobile phone. Will it also work on all devices, or do we have to handle all the other devices?
So it will work on basically anything with the browser. I think it's technically broken in like Internet Explorer, but hopefully no one's being forced to use like Internet Explorer 10. Yeah, it works across all of the major browsers, both desktop and mobile. And I mean, because I like my free time, I haven't tried, but I'm sure you could also load it into the browser on like a PS4. I don't know why you would, but you probably could.
So what else can you do here? So I remember with COVID Risk app, you had different tabs where you had a tab for general risk, you had a county level map for the US, and then the other. Can you achieve that from from Shiny as well?
Yes, that application is actually based on Shiny. So let's go ahead and pull up COVID Risk actually. So this is based on our Shiny. Admittedly, I wrote most of it in, I think, like 4 hours at like 1 in the morning because Joshua really wanted to get this out there pretty quickly. So the code base is kind of a mess.
Wait a second. All right, sorry. No, I'm supposed to be on mute. Let me go back on mute.
So code risk is based on Shiny. So each of these tabs then is a different UI element that's running different R code to make it work. Then similarly on shield immunity, the way we've actually designed shield immunity is each of these interactive pages that you see is actually designed as its own standalone mini R application in Shiny. So we've split apart all of these applications to be one small standalone piece. That's just to make development a little bit easier and deployment a little bit easier. But yeah, let's actually pull up an example that's included on the GitHub repo for this session for how this works. So if you have stuff downloaded for this session, this 06 Hello Navbar is actually a good place to start. So this actually is using a layout known as the navbar page layout. It again comes from Bootstrap, and it produces a page then that has this navigation bar that has tabs. So just like Fluid Page before, we start up this UI by saying navbar page. Previously we had Fluid Page. Title here is going to be the title that shows up, say, in the tab in Chrome. Then we give this the ID of navbar. And then within the navbar page, then we can define individual tabs. So David asks if the Shield Immunity site is available somewhere.
I can provide the GitHub link. Aroon, you can continue.
All right. So in order to set up these tabs, we use, again, another function called a tab panel. So in Shiny, actually, we can reuse tab panels across a couple different UI organization techniques. And all a tab panel is an individual set of UI code that will be shown to a user when you visit that tab. So for example, here, we have tab 1 over here. And when you visit tab 1, you get the content for tab 1. In this case, it's hello from tab 1. Same thing happens down here with tab 2. If we were going to go and click on tab 2 here, we get hello from tab 2. So as you build larger and larger applications, it often helps to split apart the functionality across these different tabs. Especially for dashboards, it's helpful because you can have individual, like standalone bits of analysis that are self-contained all on one page. So that way you're really only showing exactly what you want to show and telling exactly the story you want to tell for that subset of the data. It helps to make sure that you're not overloading the people who are trying to look at your dashboard. And ultimately, you want to be able to look at all that data that you're seeing on screen at a particular time and understand it. And for maybe the COVID risk, it's not a big deal if it's all on one page. But for larger dashboards, it can actually get quite tricky if you have a lot of distinct pieces of data all on one page, or at least being able to be seen all at once.
Is there a difference in performance when it comes to doing this tab-wise? So I understand the different in organization and the development aspect, but what about performance?
So there are some performance issues depending on how you decide to architect your code. One of the big limitations of Shiny is how it's been designed essentially to run its code internally. It's what's known as a synchronous programming language. R is in general. And all that means is it will run things one at a time down the page. And in terms of Shiny, that means it will run whatever the applicable code is for one user at a time. So if you have two users trying to use your application at the same time, when one starts something, effectively the other user has to wait for whatever code is running for user 1 to have their interaction finish, then user 2 gets served. And there are ways to architect your code to get around this, but for most dashboards, this isn't a big deal. The interactivity and the length of time spent doing computations is small enough that you're not too concerned about this.
All right, so this is all great, but the next question for me is all of this, you've been running it on your own system. How do you take this application and put it on the web? How have you been able to do it with the Shield Immunity or the COVID Risk app?
Sure. So both COVID Risk and Shield Immunity run on their own standalone servers or VMs, depending. But the way they're deployed is actually via containers, which we can sort of get a view at here. So I'm going to go ahead and use let's deploy this application. So in RStudio, there's functionality known as RStudio Connect. And all that lets you do is essentially click this blue button up here, and it will deploy, say, your Shiny application to a server that's publicly accessible. So it uses, again, the shinyapps.io system, and there are free accounts that are fairly generous in like the usage that you can have. Let's go ahead and deploy this guy. We'll call this guy 1.5 bar. So what this does when it goes to deploy it, it actually does something very similar to, say, how I deploy Shield Immunity or the COVID Risk app, where it takes the Shiny application, it figures out what dependencies it has. So in this case, it's what packages and libraries are being loaded. We're really only loading the Shiny library, so nothing special happens there. And then it effectively makes a container. So it takes your application, it does all of the compiling necessary to make it a standalone piece of code. It puts it in a container and then uploads that container then to the server that'll be running it. So this usually takes a couple of minutes, but it's a pretty small application though. So as you see here, as it's scrolling by, you get this thing that says pushing image, but it's actually effectively a Docker container that's been created and will be running your application. It takes a little bit for it to happen, but it should be soon. There we go. So what Shiny Apps then does is it, again, takes your application and puts it up online. So I've gone ahead and pasted the link for this in chat if you guys want to look at it. But it's, again, exactly the same application I see here locally deployed to the cloud. So this works pretty well if your application either doesn't have any local data, or if it does have local data, it, like, say, fetches that data from a remote source, and then, like, stores it locally. But it sort of falls down when you have a lot of custom data that you want to use. And that's mainly because you're limited in the size of things you can upload to Shiny Apps.
And how were you able to, so we followed that click over there and that just pushed it, but do you need an account for something on the Shiny Apps?
Yeah, so you need a Shiny Apps account. And actually, I only really use it for teaching again. So I only have a couple applications in it. But once you sign up for a free account, it'll have you connect your account. And all you do to connect it is go to, on your dashboard, you go to tokens. I'm not going to show you my secret, but effectively you click the show button, and then it will give you the option to copy and paste this code. So you'll copy and paste some code here, paste it into RStudio down here, and that'll link your account from RStudio to then Shiny Apps to doing your deployment to the cloud.
And how do you manage it? Could you also talk about that a little bit? How do you manage an app that's running?
Sure, so if we go to our dashboard, see that I have a couple different applications. Let's go ahead and start them. Right now, I only have that thing, which is the Hello Navbar app that we just deployed. I also have one that's in SIR simulation, and I have one that's actually, I think it's the same SIR simulation. I just named it something else. I can go ahead and click Start on SRID. We click the link for it. It opens up. So the way you manage it is all then online. We have, again, shockingly, a dashboard for looking at your applications. So it gives you some data that you might care about if you're either paying for this or if you're worried that you're going to hit the free limits. So it gives you the amount of hours that your application has been running, when the last time you, or I guess the first time you deployed it, the last time you updated the code, and when you created it. If you happen to go on to work for, say, a company that has their own like professional version of Shiny Apps, you can actually download the image that you created in RStudio and upload it to your internal Shiny Apps Pro instance, and you'll have the exact same application being run. And just like that, you can also stop your instance for it. If you want, you can also delete or restart your application, or look at, say, the logs that are given out if you're getting an error. I don't think this one has any logs, or at least nothing useful. Yeah.
This was very useful, Aroon. Thank you very much. We have a little bit of time remaining, and I know we've also have, we can also talk about how you've done the deployment or handling of larger application, but I'm gonna allow participants to ask some questions before we get there. So if you guys have any questions with this very, very, very high level overview of how you can make your own dashboards, simple dashboards, but your own nevertheless. Do you have any questions for us? right? Well, while we're waiting for the questions, I'll ask Aroon to take us through the final thing, which is how do you handle these, or how does this development and deployment look like when your scale becomes larger? And this time with scale, I'm referring to more the traffic on the dashboard. So with a lot of these applications, we've gotten a lot of traffic. How have you been able to handle that?
Sure, so let's pull up the slides again. So COVID risk is actually a really good example of like larger applications that we've had to deploy. This came about almost a year ago today. That had some ideas on ways to personalize risk for COVID-19. It's like fairly difficult for people, like me included, to take the idea of, oh, there's an infection rate of 17 per 100,000 in my area. It's hard to take that number and then give it like a real risk value for whether or not I would be comfortable doing something. So actually Joshua tweeted out a, I guess, now famous image of the potential risk of going to events of a couple different sizes, starting with say a small group dinner of 10 people, going all the way up to his favorite sport, going to an Atlanta United game. And we wanted to, like that first time he tweeted it, it got a ton of traction. But then Joshua was sitting at his office every day creating updated images and graphics. So he reached out to us and said, can you help me take this thing where I'm sitting at my computer and doing it myself and scale it into a website that people can go to and look at own area at different risk size and say, here's what my potential predicted risk is. So that's really how this COVID risk assessment planning tool was born. And over the last year, we served about 8.5 million users, and that comes out to greater than 50 million risk predictions. At some point, the server we'd set up for doing analytics just couldn't keep up with the flow of users and sort of just gave up. But at our peak, we served about 10,000 visitors every minute, which isn't a ton if you're, say, a normal company like Google or something. But for academics, that 10,000 people per minute is, or like 10,000 people is usually more than like ever visit websites we make. It's actually a pretty unique challenge for us for scaling. It was made slightly harder because at the time I was an academic and Joshua still is, and we're sort of loath to spend money on things because it's hard to get money in the form of grants. So we like to use free and open source software. That's what the Shiny server that we're using today is as well. It's free and open source, but they have a paid offering that scales automatically and much more nicely for larger flows of individuals. But we didn't really have that available to us because I think it's like $10,000 or $15,000 a year. So instead we do something called horizontal scaling. And what horizontal scaling is one instance of Shiny server is a free open source version. It's really good at serving, say, 50 to 80 people. So we can make many copies of that same server, and that's essentially multiplying the number of users we can serve. That's exactly what we did. At our peak, I think we had in the ballpark of 60 different instances running, which gave us the ability to serve about 12,000 users at once. This is actually a really big collaboration between Troy Hilly here at Georgia Tech, and then actually a lot of the IT individuals at the institute level to get us all the resources we needed. And the way we did this setup was actually by containerization. You guys may or may not have heard of something like Docker. That's exactly what we used. And all a container is it's taking your application, all of its code, and all the things you need to run it and putting it in one place, essentially. And that one image you can transfer around from your computer, someone else's computer, to a server somewhere in the cloud. And it will almost always work exactly the same way. there are very few cases where it doesn't. Actually, so if you want an example of a pretty basic Shiny application that's been containerized, you can actually look at the Shield Immunity website that I think Joshua's put the link for that in the chat. And it's, again, a couple different small applications. They've all been containerized so that we can take the applications, put them on the website, and if we need to, we can scale up the number of instances we have.
Now, Aroon and Lava, I wasn't necessarily planning on jumping in, but I hope you don't mind if I ask a question.
Go for it.
You've given these examples of sliders and plots and interaction. Yesterday, going into this morning, we had these dynamic models where these are parameters really in terms of an epi model. I think Seth made an interesting note about taking the model output and trying to use that as the basis for a plot command. Now, there's this one calculation you had with just essentially looking at as a normal distribution. Can that be replaced with the equivalent of an ordinary differential equation solver? Is that, in a sense, all that is that could take us as the gap to the next step?
Exactly. It can be. So in this case, so that's what the number 8 but its number 8 example is on the repository. Oh, come on. So if you have the data downloaded for the session, this 08 model, the SIR model, application is actually exactly what the Shield Immunity model is. It's just done with all of the base Shiny input, outputs, and theming. So if we look at this, we're sourcing this giant URL here, which all that does is it loads the code from this R file. I've put here. And this R file actually contains an ODE model for solving the Shield Immunity model. In this case, it actually has 3 different variants of that model: the core model, the hard, and then the flexible model. And depending on, go ahead and start this application.
Maybe it's worthwhile, as you're doing that, I'll just to talk over this a little bit. For those who are not familiar with the Shield Immunity concept, it's basically an SIR model with feedback where the number of recovered individuals, if they elevate their interaction, the shielding parameter ends up diluting interactions with susceptibles, decreasing the force of infection. So for all those listening in, this in essence is just replacing those SI.R. equations with a slightly different version and seeing an epidemic unfold with that feedback. So that's, I think, where we're about to load and share.
Yep. So this is essentially just an extension of what you've already seen. It's using a slightly different layout. You'll see that it has, on a wider screen, it has this side-by-side layout, so it's slightly more compact. But it's all bits that you've seen. We have a slider input here named alpha, which is the strength of shielding parameter for this model. You have another slider input that's transmission rate or beta parameter for this model. And then finally, we have radio buttons. Radio buttons are these guys down here. They're just a way to give a single choice across a list of choices. And so when you vary these guys, what happens is, so if we pick conventional here, we have beta set to 0.2 and alpha set to 2. We go down to the server function. We actually set up then that modeling. We have a parameters list called pars. So inside of it, we have essentially a preset gamma. We have this y naught that has actually been supplied by Joshua as the initializing value. finally, we have t, which is the number of days that we run this model out towards. And you'll see here something we've already shown you, which is this render plot function going out to this plot called p_model. And we, again, take those inputs, so the slider for alpha, and we assign it to the parameters list alpha. We take the slider for beta, we put it into the parameters list and call it beta. And finally, we compute out the R0 for this theoretical infection by dividing beta by gamma and store it in an R0 variable in the parameters list. And then finally, we want to know what model we're going to store. So this is these radio buttons over here, and we just store that in its own variable. And finally, we run the SIR. We run this SIR shield function, which is this guy over here. And first, it looks at what our radio button is set to. Right now, it's set to conventional, so it would run this core model. And again, all that core model is this ODE over this equation. And we take the output of this model, and that's what the model output is the output, and we're plotting.
Can you go back? I know you popped over just for a second,
Yep.
just so everyone can see where the actual differential equations show up, since that is the exact link. So it pops into one of these sub-functions that define, as we've been doing, the dsdt, didt, drdt. Is that right? And so it just sort of leverages the internal workings of R's ODE function, where you've specified the function here that and
Yep.
the parameters that come from the user.
Exactly. Yep, and then we're taking that output and we're just plotting out the infections over time from it, which in this case was a column named I. And Seth, to answer your question about hosting Shiny on AWS, yes, I have, I think at this point, 5 or 6 fairly large applications hosted on AWS or Azure Cloud, depending. But it's pretty straightforward. It's essentially the same way that you would host any containerized application.
Aroon, before we move towards the end, I just want to kind of go back here and talk about this from the code organization point of view too. So by separating these out into 2 different scripts, how is it helping? Can you talk more about it a little bit? So how does it help that you have the SIR shield function in a separate script?
Sure. So actually, when we did this development work, this file was actually created by members of Joshua's lab. So I think actually the original model I think was written in MATLAB. They also have ports of it to Julia in R. So we went ahead, and this is actually code directly from our subject matter expert, that is our mathematical modelers. Because honestly, I'm not a modeler. If you gave me suggestions on how to do this, I would probably still fail. I should probably take this workshop, learn how to do modeling. So this is actually from people who we consider experts who have written the model, validated the model, and said it's correct. And then, so we take their code and we import it into our own. So it's a great way then to separate out the different concerns in the application. So like Lava, you and I are concerned about getting the application deployed and have it be interactive and make it so users would enjoy using it. And that's not to say Joshua's not concerned about it. I mean, he really likes playing with these applications, so he also wants them to look nice and be nice and interactive. But he's also very concerned that the underlying code and models being used are correct and representative of whatever situation is happening. So it's nice to be able to separate out the model code from the application code. Because that way, if our subject matter expert says, oh, we need to tweak this or tweak that, they can actually do those tweaks on their own. They can essentially pass us this new file and say, here's an updated model for you to add to the application.
And just from our experience now in dialogue here, for those listening in, I mean, I found this to be very much a new experience for us as a team, but I like this, what I would consider a modular coding approach, that we focus on our materials and really can in the sense of understanding and specifying what we're handing off to Aroon and Lava and their team, exactly sort of a pre-specified agreement, a handshake that, yes, we're going to, as long as you give us these right inputs, we will give you what we perceive as the right prediction in the model. And that allows both of us to focus in on where our expertise lies. And so, at least from our side, as folks focusing on the epi dynamics, this has actually helped us a lot focus in and learn in the process, but not necessarily have to recapitulate all these cool things.
Yes, like a lot of the things that Lava and I work on, they're with groups that are like very like steeped in whatever they're working on. They may be experts in a particular infectious disease, or like Joshua, they may be experts in doing modeling of complex systems. But they aren't necessarily experts in taking these like academic models and then putting them into say, an application like this. That's where Lava and I step in. We say, okay, we can work with you to take your code, make it into an application that you can then share with others.
I do want to echo the two comments that are here in the chat by Seth and someone who's named S. The separation also helps when, for example, if this SIR code was a lot more complex, or if you wanted to make it more complex, the separation of code is a lot easier to handle as a human, right? I mean, computer can handle whatever, but as a human, it's a lot easier to work through, okay, this file contains only the set of instruction. And as Seth said, it also makes version control a lot easier too. So both of those are good comments. I just wanted to point it out here.
So like as an example, I have an ungodly large shiny application that was written for doing a lot of like pretty complicated data analysis on cancer genotype expression in proteomics data. And I think it's pushing about 5 or 5,500 lines of code. So a pretty large set of space. But yeah, it's split across 20 or 30 files because otherwise it'd be impossible to scroll. Like I'd spend a very long time scrolling up and down the file to figure out what I was trying to change.
Right, so I think that brings us to the close of our session here. We both sincerely hope that this was informative for you guys. I mean, if nothing else, if it allows you to, or if it reduced your inhibition to trying these things, that was a worthy investment of all of our time. We're gonna be here for a few more minutes. If you guys have any questions for us, any thoughts that you'd like to share. But Joshua, I don't know if you have any other closing comments.
I'll make a few announcements in a moment, but let me, on behalf of those in the audience, and if people can feel free to just type whatever in the event chat, to say thank you both to Lava and Aroon for developing these materials. And I think it would be great just to point out on the course website, and maybe as I'm chatting, whether Jessica Audrey want to type that in or Lava, that we already have a link to the GitHub site from our materials. We will be posting the slides because as you did your clicks, those materials are sort of allow someone to walk through and recapitulate what you've done. So everything that you went over today is available freely on GitHub. So I think at this point, it would be best, since we've been going for about an hour and a half, and this is, by the way, day 2, and they've learned how to, some folks are just starting from almost no coding. We have a spectrum here today, and we've been teaching folks in MATLAB, Python, and R, and they've been doing a lot of coding the last couple of days, to take questions, and as we've done before in these events, anyone in the audience can feel free to ask a question in the Q&A session. There's a Q&A link, and that's the best way because people then can like it, and we can reinforce that. So why don't we switch into that mode now? And feel free, anyone in the audience, to go ahead and just post your question. And again, since I'm semi-moderating here, and for those who might take them a little bit to ask, maybe I will again start. When it comes to the capabilities of, let's say, real-time response, so some of these OD models could take quite a while, right? So the user does something, and then it starts to compute. First of all, I wanted to ask about computing versus pre-computing. When do you decide to compute on the fly versus pre-compute? And is there any way to let the user know that that computation you just asked for might take a while? So maybe both those two, and I see some questions are starting, so I'll let you handle those first.
Sure. So I guess we'll start with the second one first, for when you would do computation versus pre-computing. So for example, on both the COVID risk site and Shield immunity, the default like output of all the models is actually pre-computed. Even though like the Shield immunity model doesn't take a ton of time to run, maybe 5 to 10 seconds, we want it to be like pretty quick for people to see at least the initial state. So for there, I've actually pre-computed a baseline initial state for everything. And that's actually also helpful because we refer to that baseline later on. If they maybe change the user parameter selection, we still show them that baseline. So it has like a sort of nice play there. And on the other question, which I think was more about like speed of development, you can get, I've probably shown you here, you can get a pretty basic Shiny app out the door pretty quickly. Like tweaking the visuals and getting, setting it up for scaling can take some time though.
This nicely also connects to Varun's question here, which was what was the design process like for making the COVID event risk planner map? There's a lot of back and forth that we had, but I guess just wanted to go back to Arun's first comment there with respect to the pre-computation. Over there, what you're really doing is to make things responsive. You're sacrificing the memory over your compute. So you're saying, all right, you know what? It's easier to store this extra few KBs or maybe a few MBs of data than to go for doing the or spending some time and having the user wait for the computation to finish. And then now going towards the design process, I think this was it. When we first started doing it, a lot of this wasn't your traditional software development process because a lot of these requirements were constantly evolving as we were developing these technologies. And it was mostly because we were all trying to figure it out. What is it that is useful? And the big thing that is needed in these cases is a vision, and that's what Joshua was. That was Joshua's role. He had the vision on this is exactly how it should look like. Once you have that sorted out, we did more or less an agile process for developing the software where we divided it into smaller goals that, okay, this is a map that we first need to knock out, or this is an application that we first need to knock out. We'll focus our efforts on that, make that application, the dashboard, as exactly as Aroon showed, and then we'll go and push it back into that bigger project. Aroon, if you anything else that you'd like to add to?
Yes, this was actually like a very strange time of, I think, everybody's life, but like particularly mine. I was getting ready to defend my PhD. I was creating the first version of like the MyTest site for asymptomatic testing on campus. And then Joshua emailed and was like, do you want to do this dashboard? And it's like, yeah, that sounds cool. Actually, I think we have, I don't know, a 50, 60 email long chain where you sent me something, I replied back with like a screenshot or some code. We passed it back and forth quite a bit. We eventually settled on this final code. But for example, like the maps that are on the COVID risk site, they're developed by someone else, by Schol Lee and Cleo Andrus, who are really the GIS experts that we went to for doing that map development. And we took their map code and transformed it into something that would work then to serve these interactive maps to a lot of people. So originally their map code actually would recompute all of the counties every single time someone loaded the page or changed the slider. But that would take 30 seconds per person. That was really slowing us down. So we actually iterated on that and said we pre-computed all the maps. So we had a set number of ascertainment biases we could choose from and a set number of people who could be at the event. So it decreased somewhat the flexibility of the application, but like greatly increased the responsiveness and the usability of the application.
Maybe I'll jump in there as well, since talking about this development process is obviously hard when one is responding in the midst of a pandemic. So I don't think this was probably what we would call a conventional design process. And the reality is that this has been, as Aroon said, a very challenging time on many levels. And I put in the chat just the concept idea at the time was to try and give folks, individuals, as well as public health authorities, some understanding and intuition that even though there were apparently very few cases that had been ascertained or discovered in early spring 2020, it was likely that in sufficiently large events that there may be individuals who were infected, potentially asymptomatically, and that could lead to spread. Unfortunately, that is precisely what happened, that events have been one of the major drivers of spread. And our effort, collaboratively enabled by the work of Aroon, also collaboration between folks in our group, some of whom acted as instructors, including Stephen Beckett, even a student, I think, here helped with us, Mallory Harris. I think she's here, maybe even in the audience. Soha Lee, Cleo Andrus, Troy Hilly, Kwon Nguyen, myself. We ended up having really a kind of a tripartite design, which is that we were working on, my group, the epidemic side of the modeling. Cleo and her team were focused on the GIS side, and it was made possible through this interaction with Aroon. And then we took and leveraged lessons learned there to have much more of a deliberative design process with the shield immunities. So that is one where I think we really were thinking about specifications enabled through dialogue with Lava, where we get to this understanding of what's going to happen. Obviously, in the case of this risk site, I think you noted there's been more than 8 million folks who visited the site who've asked for 50 million plus risk assessments, and that continues even now. So that kind of demand is beyond the scale and scope of what a typical academic group can do, and it does require a different sort of interaction. And it's been enabled clearly by our studio, has done a wonderful job in helping us make this possible and scale this up as well, and we're grateful to them. But I don't know if the lessons learned from our design process really are the best ones, because we were responding really in a crisis situation. The shield immunity is one where I think we learned a lot from that. But there is an expectation of iteration, right? And just from my perspective, and I think I try to be very grateful, not only in my team, but in working across disciplines. But I have very particular ideas of what I want in mind, because we want to make sure the subject matter is right. And I think that's just part of what you have to realize you're going to get yourself into when you enter one of these partnerships, that both sides are going to want to make sure that the infrastructure development is secure, but the responsibility that the subject matter expert has, be clear about what they need in advance, and then to really work hard to make sure to communicate that on the site. And again, let us thank virtually, or you can in the chat, Aroon and Lava for this terrific, informative presentation, all of which with best practices available on their GitHub site, link from ours. So thank you very much, Aroon and Lava, and we'll go into break. Thank you.